Hello everybody. So today we're going to continue our discussion on integration by substitution, and we're going to deal with problems where we have the natural number e raised to u and problems where the actual derivative of u is over u and how we handle those, okay? So our first formula is if I'm integrating eu to the du, that's simply going to be e to the u plus c, okay? So we're going to go through some examples of just exactly how this would work, because we're going to have to do substitution. It's not just as simple as that particular one seems, okay? So our first example is going to be the problem of the integration of e to the x cubed x squared dx, okay? So obviously if I'm looking at this and matching things up, I would say, well, the u has to be x cubed, which would mean that du is 3x squared, right? But if you'll notice, I don't have 3x squared here, do I? So in order to do this, remember we talked about the inside and the outside. So I'm going to change this to the integral of e to the u, making my substitution. And in order for this to work out, I would actually have to go in and say 3, right, times the x squared dx. Now, do you see I have the du? Okay, so now I can make my substitution and say it's the integral of e to the u. But if I put that 3 in here, right, I have to put that 1/3 out here. So I have 1/3 e to the u du. Well, if I have the integral of eu du, I know it is simply eu plus c, right? But then I have to account for this 1/3. So when I'm going through this, in order to make this work, I have to get my du set up just like I did before in the other problems where I was just integrating u in to the d times du. So let's look at another example and see how it would work. So I'm gonna just separate these two. I should have had a dx there. So let's look at the integral of e to the radical x, x to the minus 1/2 dx, okay? So obviously here, u has to be radical x. And I'm gonna go ahead and say that's the same thing as x to the 1/2, right? So let's see what du would be. Du would be 1/2 x to the 1/2 minus 1, or 1/2 dx, okay? So what am I missing here? Aren't I missing this 1/2? So the integral of e to the radical x, I would need the 1/2 here, x to the minus 1/2, okay, dx, in order for this to be e to the u du, right? So if I have to add in a half, I have to multiply by its inverse in order to make this cancel out. 2 times 1/2 is 1, and I get my original equation. So now I end up with 2 eu plus c, right? And then I substitute back in my u, so 2e to the radical x plus c, and then that would, of course, be my answer for that particular problem, okay? So it's the process is really staying the same. We're defining what u and du are. If du doesn't match up, then I'm using the inside and outside method that we talked about in the previous lesson, okay? So that's how we go about integrating e to the u. So let's look at the integral of du over u, and the formula for that, and you might see some representation of u to the minus 1 du, is simply going to be the natural log of u and its absolute value of u plus your constant, okay? So let's go in here and look at some examples. And we'll just start off with the basic example. Let's say we're taking the integral of dx over 3 minus x, okay? So I'm going to say, well, u is 3 minus x, so du, well, the derivative of a constant is 0. The derivative of minus x is minus 1. So it would just be minus dx, wouldn't it? Well, I don't have minus dx up here. So I'm going to have to add in a minus, and I put a minus out there, right? Now I have this form of du over u, don't I? Because there's my du, here is my u that I brought out. Well, now I'm going to have minus 1 times the natural log of the absolute value of u plus c, which means I'm going to have minus the log of u, 3 minus x, plus c, okay? So here again, it's all about what is the u in the initial equation and what is du, and do I have to make some sort of inside-outside change in order to make that happen? So let's see if we can pull up another example here. And this time we'll make it a definite integral. So we'll take the integral from 2 to 3 of x squared all over x cubed minus 7 dx, okay? So right away I can see a derivative here forming, and so I'm going to say u is equal to x cubed minus 7, and du is going to be, well, the derivative of x cubed is 3x squared. The derivative of a constant is 0. So I've got du is 3x squared dx, okay? So let's set this up from 2 to 3 of x squared, x cubed minus 7 dx. So in order for this to work, I need this 3 in here, right? So I'm going to add my 3 and multiply by 1/3. So now I have 1/3 the integral from 2 to 3 of du over u, okay? And I know from my formula, I've got 1/3 the natural log of u plus c from 2 to 3, okay? So I know my c is going to subtract out, so I don't have to worry about that anymore. So I'm going to have 1/3 times the natural log of 3 minus the natural log of 2. Okay? Well, 3 and 2 are already positive. So really, this boils down to ln of 3 minus ln of 2 all over 3. And of course, I can plug in ln of 3 and 2 into my calculator and get the right answer, or the final answer, right? But I'm not going to at this point. That just introduces round off error and things when I'm looking at that. Okay, so anyway, it's all about finding the u and the du and making that adjustment, this inside and outside adjustment in order to do that derivative. So really, when I'm talking about integrating the natural number and u to the -1, if you want to call it that, with respect to this process of substitution, it's all about, again, the same process, figuring out if du exists and then adding into the equation the inside and outside factors to make it all work. So if I'm integrating e to the u du, it's going to be e to the u plus c. And if I'm integrating du over u, my answer is going to be the natural log of u plus some arbitrary constant, okay? So that wraps up the discussion that I wanted to have on integration by substitution. And so I will see you guys next time.